RK sir, are you connected with us? Shall we start?
Yes, madam. I am connected and ready also.
Okay, sir. A very pleasant evening to all the distinguished panelists and the participants. Bharati Vidyapeeth Institute of Computer Applications and Management BVI CAM in association with Computational Intelligence Society chapter of IEEE Delhi section, Computer Society chapter of IEEE Delhi section, Technology and Engineering Management Society chapter of IEEE Delhi section, System, Man and Cybernetics Society chapter of IEEE Delhi section, Communication Society chapter of IEEE Delhi section, Consultants Network Affinity Group of IEEE Delhi section, Life Member Affinity Group of IEEE Delhi section, Inter-Society Relations Standing Committee of IEEE Delhi section, Industry Relations and Standing Committee of IEEE Delhi section, Industry Relations and Special Interest Group on Humanitarian Technology Standing Committees of IEEE Delhi section with the associations Computer Society of India, Institute of Information Technology Professionals, IITP, ISTE Delhi section and IETE Delhi Center as technical collaborator welcomes you all to the webinar on the topic Compression, the Heart of Digital
हाँ
Revolution.
डॉक्टर मैं
It is
वेबिनार
a
शुरू कर
moment
रहा हूँ
of
अभी
pride and
आफ्टर सेवन
honor
थर्टी
to
आपको नहीं
announce
करूँगा
that
7:30
we, with united hands, mark special
हाँ वो है
contribution for the monumental occasion Azadi Ka Amrit Mahotsav, an initiative to celebrate 75 years of glorious independence by organizing the thought-provoking sessions for our better future. This webinar is one such initiative for celebration of Azadi Ka Amrit Mahotsav. As a matter of fact, when compression technology came along, we thought the future in 1996 was about voice. We got it wrong. It is about voice, video, and data, and that is what we have today on these cell phones. Compression process has different meanings in mechanical, chemical, civil, and metallurgical engineering. But the moment we think about compression in electronic and signals integrated with computers, telecommunication networks, and consumer products have fueled the digital revolution. At the heart of this revolution is the digital compression of audio and video signal. The compression of digital revolution is like that of the human body. The way proper functioning of heart is essential for human body to survive. Similarly, proper compression is necessary to make digital revolution a complete success. Compression has now reached the stage where it can economically be applied to video and audio systems on a wide scale. This webinar aims to discuss various acts of compression and it would be discussing all the possible opportunities. I would first take this opportunity to welcome amongst us our distinguished panelists for the day. We are privileged to have amongst us a galaxy of experts. I would, on behalf of PBI Camp and all the organizers, would like to welcome our expert speaker, Mr. R.K. Singh, sir, with an e-bouquet. We welcome you, sir. I think the rights are there with you. So we welcome a warm welcome to Mr. R.K. Singh, sir. Mr. Singh, sir, has over 4 decades of experience in the field of broadcasting sector, including of operations, general management, procurement, technology, and human resource development. He has extensive experience in complex and challenging international and multicultural environments with proven ability to represent the organizations among stakeholders and strategic partners. An exemplary communicator with proven skills in designing and conducting customized training programs geared towards optimizing knowledge and operational efficiencies of employees. Sir has also expertise in conducting training programs and workshops in the areas of managerial effectiveness and broadcast technology. He has represented All India Radio in international seminars and conferences globally. Sir has also served to the government of Kenya, Nairobi, for a period of 5 years. a renowned expert on the panel of DOAC Society for inspection and awarding accreditation to Computer Training Center and bestowed with many eminent engineering awards and accolades. Sir is the fellow member of professional bodies like IETE, IEBES India. We are honored to have you amongst us, sir. I would now request you to please acknowledge and enlighten the House. Please, sir.
Okay, madam. Thank you very much, and uh, good evening to all of you. Uh, Madam has already mentioned little bit about the topic compression, which I have given the title as the heart of the digital revolution. Well, this is how important compression is in our life. It is very clear from the topic that if the compression is not there, probably it will be difficult to survive in digital revolution. And we all know how important digital revolution is. I mean, today everything is being done, evolving around the digital things. Now, this particular thing, uh, although I have got a bit long my agenda, it is in two parts. But anyway, I will be trying, and I will be taking only video compression today. Later on, if you people like, we will see if the organizers agree, we will go for the audio because taking both is certainly not possible. So, and I will be starting from the very basic so that those people who are uh, not familiar, I mean, then they will also get some idea and then they will also join me. I will try. So, for my first slide, first thing is why compression should be necessary. After all, that should be the basic question about the compression. And this I would like to explain uh, simply by asking a simple question that how many bits are generated by simple digitalization. Simple, that is sampling and quantization. You do it most of you, all of you must be knowing about this. So 1 second of video and 1 second of audio, if we digitize, if we take the analog video or analog audio and then digitize, how many bits we will be generating. So this will give me, video will give me 216 megabits. Of course, we have to take care of the sampling frequency and the quantization also. And this will be clear from this slide that the sampling is at 13.5 megahertz and sampling is at 6.75 megahertz, and quantization we are taking about 8 bits. So we are getting 216 megabits, and that's a huge quantity. And I will give you a simple example that when we transmit our TV channels, most of the TV channels when we are just transmitting 5 to 7, even 5 to 7 megabits per second is also on the higher side. It is generally lower than that. Then the question comes, when we are generating, it is 216 megabits, but we are giving to the public, we are giving to everybody only 5 or 4 or 5 megabits per second. So how this happens? And this is achieved, in general, I will tell you, then we will go into the detail. This is achieved by exploiting limitations of human visual system. See, after all, God has given us eyes, ear, and mouth. And when you see any picture, this is our limitation of our visual systems are there. So normally we exploit this human visual system to reduce the bits. I think that will be clear as we proceed further. And how this is done, what limitations, well, this is done by some art, trick, or jugglery, to remove the huge quantity of remaining bits. That means from 216, we are using only 5 or 6 megabits and removing all the remaining bits. Now the same thing is happening with the audio also. If 1 second of audio we simply digitize, uh, then it gives 1.4 megabits. And if you take the stereo channel and quantization, of course, as we all know that our ears are more sensitive to uh, uh, our ears are more sensitive than our eyes. So it becomes about, if you take everything, it becomes about 4.32 megabits, or even in dash, it becomes 3.08 megabits. So in audio and video, both. Otherwise, I will give you a simple example. I think all of us, we are very, very familiar with MP3. MP3, everybody knows. And if I ask you that in one MP3 CD, how many songs are there? Then somebody will say, sir, 150, 170, and all that. So huge. Many, many songs are there. Can be accommodated in one CD. But when you record it, or without any jugglery, that means without any compression, if you record the songs on a CD, you'll be surprised that we can record only 4 to 5 songs in one CD. So that is a huge difference. But MP3 is popular because, after all, techno economics come into picture, because people would like to buy 150 or 170 songs by spending only on one CD. But then if you go by the purity and this and that, that also we will see, then of course it will be only 4 or 5 songs. Without any compression, technically I can say, without any compression, you will be recording only 4 to 5 you know uh, songs only. So again, how this is achieved? Well, this is achieved by exploiting the limitations of human audio system. So in both the cases, compression, video, by exploiting the limitation of our eyes, our visual system, and in audio, it is done by exploiting limitations of audio system. But today we will be discussing the human visual system and how it is exploited. Okay. Now, friends, before we go into the detail, what I felt that I should give you some feel of compression, because unless you get the feel of compression, probably you will not appreciate my thing. Feel means you should know what is happening. Yeah, and this I will give for both, for audio, for video, as well as audio. So just see, I mean, experience, you yourself experience what is video compression without going into the detail, without going into the detail. You just see this stuff. So let us experience this video compression before we make an attempt to understand this exciting technology which is responsible for digital revolution. So before we go into the detail, how video compression takes place, uh, we will try to give you a feel of it. Now, I will give you pictures in the next few slides, and you see those pictures and make your own judgment. Well, this is the two pictures of some famous actor you all know. And there are two pictures, A and B. I will request all of you, I mean, those who have got mobile or any paper or pen, just say which is better, because there is a difference of compression, there is a difference in number of bits used. And mind it, probably sometimes I may not remove the bits also. So I'm just testing your eyes whether you can make out these two pictures, which is good, which is bad. So you have to just make out. Uh, there are three options. Whether quality of A is equal to B, if there is no change in quality as far as your eyes or your visual system is concerned, or quality of A is better than B, or quality of B is better than A. So these are the options before you. Just write for this movie, I mean these two pictures, write whatever option you have selected. Okay, because I will be giving you few more pictures, right? I don't know whether because normally people say sir एक बार दोबारा दिखा दीजिए, you know, you want to see again. I can show you again this picture. Okay, right. Now I complicate the problem little bit more. The same picture I am giving you in four A, B, C, D. Again the same thing. All these four are using different number of bits. In other words, I have removed the bits from these pictures in a different way. From some I have removed more, from some I have removed less. So again, here you can write, you can mention it like arrange the pictures in decreasing quality order. That means the best 1, 2, 3, 4. You can write in that sequence. You can have a look at it again. Okay. Again, I will give you just this is the last. Again, four pictures. I have given you the same thing, different bits, and you can always write whether they are good or bad. Now, what I do, you can compare just to give you the idea about the compression. As I told you, I want you to feel compression. Probably with the help of these pictures, you will be able to feel. Now, I come to the first two pictures, if you remember. Now, picture A is of 309 kilobytes, 309 kilobytes, and picture B is only 97 kilobytes. So you can see the difference. It is byte, not bit. So you can see the how many bits have been used in A and how many bits have been used in B. Similarly, when these four pictures are there, you can say in one I have used 308, in B I have used only 50 kilobytes, in C 30, and in D 97. But more or less, at least to me, because I use specs and I'm an old man, so to me all appears to be equal, and that is the beauty of compression. And similarly, in this also you can see that there are different amount of bits used in all the four. So friends, now in terms, or if I ask you what is your experience after watching this picture in terms of quality, well, to many of us it looks alike. Although considerable number of bits have been removed from these pictures. How these bits have been removed? Well, that is the topic for the discussion today. And how these bits have been removed using different types of compression techniques. Now, when you are seeing the compression, somebody may ask, sir, how you are removing bits? Well, it is not that simple also, but I will try to make it as simple as possible. So bits have been removed. You have got some feel of video compression. We will try to understand these compression techniques. Now we will go to that one. Okay. But before I go to video compression, why not give you some experience of audio compression also? In other words, if you allow me, I can test your ears also, right? So, and then we will proceed to video compression. Okay. So, giving you this art. Though I have got five different set of same recording. I mean, everything is same. The only thing is bits have been removed, and songs they look like. So I will just play few songs, and you can just say whether I will say I can play some three, because again the time constraint is there. So I can play, say for example, first I am playing D. Okay.
आज हमारे दिल में आज हमारे दिल में अजब ये उलझन है गाने
Is it audible, madam?
Yes, sir, it is audible.
So somebody has given message that it.
कुछ
It is audible.
आए ये उनका भी मन है आने बैठे गाना सामने समझन है
I will play it second time.
आज हमारे दिल में आज हमारे दिल में अजब ये उलझन है गाने बैठे गाना सामने समझन है कुछ आज सुनाए ये उनका भी मन है गाने बैठे गाना सामने समझन है
And last time.
आज हमारे दिल में आज हमारे दिल में अजब ये उलझन है गाने बैठे गाना सामने समझन है कुछ आज सुनाए ये उनका भी मन है गाने बैठे गाना सामने समझन है
Well, okay, gentlemen, ladies and gentlemen, I have played only 3 times, and you must have noticed also. First, I played D, then I played E, and then I played A. I avoided, just to save the time, I avoided the other two. You must have seen also, you have seen the quality, whatever it may be. Because there is no time for discussion on that. Otherwise, normally I ask who has liked this, what, and origin. So to save the time, I will straightway go to the its results. You can see now. Now you will be surprised. You will be having. Uh, First, I played D. D cut, and please note, all cuts are exactly equal duration. Exactly. So D cut was for 497 kilobytes only, whereas E was only 297, and A was uncompressed. It was having 8,760. So you can very well imagine the number of bits removed. And well, if you have any questions on why the quality, if there is any quality difference and all that, we can discuss it. But generally, it is very difficult to find out the quality. But if time permits, we will certainly discuss that. Okay. So with now, that means I have given you uh, the feel of both audio and video, and you have got the that normally this wonderful technique compression really removes the bits, and when the bits are removed, our techno-economics comes into picture, bandwidth will be reduced, and all this space will be reduced, and the quality will be very good, right? Okay, now I start, but again I will be telling this wonderful technique, particularly the uh, video compression. I tell my this analogy is very popular. In fact, for the last number of years, I am explaining. So here also I will use that analogy, and orange juice analogy. Now some of you must be surprised that how how the presenter has brought orange juice in the compression, but it is there, it is there. Now I will tell you the story. I will tell you the uh, yeah, a simple way of understanding this concept, that is orange juice analogy. Very briefly, in few seconds, I will tell you. Hey, you are having a bag. You decide to do some business of oranges, maybe in Nagpur or in some place where oranges are there. So you invest a lot of money, maybe 10, 15, 20 lakhs, and you decide that you will get these oranges and you sell it and then make money. So that was a good idea. Normally in UP we do for mangoes. We take the some bag of mangoes, and then that year we will take all the mangoes and sell them, export them. So same thing we decided for oranges. Okay, and then we said, okay, we will be making the business, but but it was your bad luck. It was your bad luck that the year you took this decision, year you invested money, that day it was a very, very bad year. You'll be wondering what I am saying. And it was bad because orange crop was fantastic. It was fantastic. Then you will say, sir, you are saying orange crop was fantastic and then it was a bad year and we incurred a loss? Yes. Why? Because after all, before business, you must have calculated that my cost price will be this, my selling price will be this, and I will be making so much money. But when the crop was fantastic, there were oranges all around. So the cost price which you calculated, it dipped like anything. And there was, big loss. But then you said, I'm an engineer. I will do something. I cannot just throw my money like that. So I want to spend some more money, and I decided that I will convert, because there are huge quantity of oranges. I will convert all these oranges into orange pulp. Buda bolte hain isko. Orange pulp, and then I will process it and I will export this pulp to the country where orange is not available, like Saudi Arabia or any other places. I will put them into the tin boxes or some and then export it. So that was my plan. That is the story. Now here I will proceed that how the oranges are converted into pulp and then uh, sent to the different countries for selling it. And at the same time, my another thing will be video also. So first, what I will do, uh, I will compare. You just assume that orange is like video signal. Okay, orange is like video signal. On the right hand side, orange is there. On the left hand side, sorry, on the yeah, on the right side, on left hand side is the video signal. Now, orange has got three things. One is the peel, skin, seed. They are just, we have to throw it out because they are not useful, isn't it? Uska chilka, uske beej, or uske, all those things. Second is orange pulp. That is the main thing. Orange pulp which we want. And the third is water. So if you take oranges, these are the three things. Now let us compare. Let us see what is there in the video signal. Video signal also has got three things, like irrelevant element, like peel, skin, and all that. And here you can say it is like noise, etc. It is just irrelevant. We don't want that. Then the core element, the real picture of the video. Okay, and then something redundant, which is not required that particular time, but it will be required later on. So I hope this is understood. That orange has got peel, skin, etc., which is just irrelevant. Second is orange pulp, which is the main thing. And third is water, which is redundant that particular time. Later on, when you are making orange juice, you can take the pulp and you can add water and make orange. Similarly, in the video signal, there is the irrelevant thing like noise, etc. which is we have to remove, they are useless. Then we have got core element, that is the main picture, main content. And the third is a redundant element. Now this we will discuss when we process that, how, what are the redundant things and how they are. So these two things I have compared. Now in my process, above you can see this line will move how the oranges are processed, and below how video signals are processed, and they go parallel to each other, right? They go parallel to each other. So something, when you bring the oranges from the field and you just crush them for the juice, no, then it will be spoiled, because oranges will have mud and all that, so many things will be, dust will be there, and so many. So if you crush the oranges like that, all these things will be mixed up and your whole orange juice will go waste. So what we do, we process, we clean it, we wash it, we wash the oranges and we remove all those things. In a similar way, when the video signal comes, there are noise, etc., and we use the filters to remove the noise. So that is the first stage. Mind it, till this time our video signal is in analog mode. Then we remove the peel and seed, etc., from the orange. Okay, we are removing the irrelevant thing. And in a similar way, from the video signal, we remove unwanted signals. That we will discuss in detail, how, what are the unwanted signals and how we remove. But their two thing goes together. Okay. Third is, now we are converting, say, analog into digital. Please note that. Now we are converting the oranges into orange juice. And since we have spent a lot of money, there are huge quantity, trucks and trucks of oranges. So when we put them in crusher, there will be drums and drums of orange juice. Okay, huge quantity, right? So when you crush the oranges, you get huge quantity of orange juice, which is difficult to handle. And at the same time, when you digitize video signal, just now I have explained, when you simply digitize video signal, and if it is 8-bit quantization, you get 216 megabits per second. In 1 second, you get 215 and then you put 6 zeros. 216 megabits. So on that one side, we have got huge quantity of orange juice, and on this video signal side, you get huge quantity of bits. Okay. Now what we do? We purchase a sort of machine. We spend some more money, and which will convert the orange juice into orange pulp, right? We convert orange juice into orange pulp. It will remove the water, it will make the paste, and then it will add some preservative so that orange pulp doesn't go bad. So all those tricks are there inside the, which everybody will have their own tricks of converting orange juice into orange pulp, right? Here also we are using encoder, and when we are using encoder, we are removing unwanted things. That we will discuss in detail as we proceed. But right now both are there. Here we are using a machine, and here we are using again a machine. This is called encoder. So with the help of an encoder, we remove unwanted things from the video signal, and there we remove water from orange juice so that quantity becomes less. Now what happens? Huge quantity of orange juice becomes orange concentrate or orange pulp. You can see that here it is reduced, right? And in a similar way, huge quantity of bits here, that is 216 megabits, we remove the unwanted thing, and then it comes back to say 4 megabits or 5 megabits or 3 megabits. Because encoder will remove the bits, compression will be there. So that is there, right? Now, what we do? Here we are doing packetization. Whatever pulp we have made, We put them into small tin boxes. We make them, marking, etc. And then we convert all that into small tin, and we call it the packetization. If you all, many of you must be knowing that in video signal also, when we are sending the video signal, it is packetization, right? And here also, when these bits have come, we packetize them. Now our orange juice is safe. It will not go bad. We can store it because preservator is there. So if you can easily preserve it or send it by any carrier. You can send it by flight, you can send it by truck, you can send it by train, or you can put it in the store. Anything. Similarly, here also, when you have removed the unwanted signals and compressed video, you can packetize, you can put it in the hard disk, you can put it in the floppy, you can put anywhere, you can store it, or with the help of some carrier, either microwave or satellite communication or anything, you can send it to any other place. Now, friends, you please note that my both the process are going together. The whole idea of doing this is that normally when we teach to the students, they will forget. But at least this orange juice analogy they will remember. And when once they remember that, they can always compare that what are the different process are there. Okay, but my story is not over. Now, with the help of carrier, we are sending it to all the places. Okay. And then here also with the help of bit streams, when once the packetization is there, when the transmitter is there, in video transmitters, whatever TV transmitters, you are sending the bit stream. So there you are sending with the help of transmitter. Now your orange juice is already in the other country. Okay. Your orange juice is already in the other country in the form of pulp, small. Now people can buy this and they will convert it into orange juice. And what is their decoder there? And in the same way, when your bit stream is going to the TV or to other places, your TV sets and all that will use decoder. Will use decoder and they will convert it into video signal. There also, what is my decoder? It is the orange pulp. A Caesar, we have to open the glass, some ice, and water. Now, water is available. See, water we had removed here, but water is available there in other countries. So we use, because that time I had mentioned that water is redundant. I mean, it is important, but not that time. So now we add some water, we add some ice, and then we add some pulp, and then our orange juice is ready. But the question is, how much pulp and how much water should be there? So there should be clear instruction written that you take 1 spoon of this or some water and all that. Similarly, for video signal, when you are there, you have to know how you have to decode it. So there are standards. And your orange pulp will everybody will not purchase unless they are satisfied that this is a good quality. That means it is branded. Only branded orange pulp will be sold. So you have to have some standards, ISI or anything. And similarly here also you have got some standards like MPEG, JPEG, H264. All those standards are there, right? And then your orange juice is ready. But please note what I have written. It is almost like fresh orange juice. It is not fresh orange juice. It is almost like fresh orange juice. If I ask you, can you convert this juice into the oranges? No, we cannot. That means this compression, this type of thing is lossless, lossy compression. Similarly, in compression also, we will study now, just now, we will study. There are two types of compression, lossy compression and lossless compression. So this is how the different process of video signal when you are compressing, and I have compared it with uh, analogy of orange juice. Madam, if there is any query or any questions, probably I may take it at this stage.
Or sir, I would like to take the question. Just give me a second. The first question that I have received is how digital revolution and sustainability revolution similar?
Digital revolution and sustainability, you can always see that now the whole life is depending on digital. And probably when we discuss further, because everything around us is digital now, whether it is banking sector, whether it is communication sector, or whether it is anything. So it has sustainability means it has to be there. That is. I mean, I need not give you any explanation for that. It is just understood. Yeah. Any other?
Other question that I have is digital transformation is a technical challenge.
Yeah.
And then to compression, your take on this.
Well, as I told you that without compression, normally sometimes when we say that we have achieved this because there was a big revolution and all that, but then we remember only few people who did this revolution. What about the people who are behind this? हम कहते हैं महात्मा गांधी ने हमको आजादी दिलाई. Yes, no doubt. But क्या अकेले महात्मा गांधी ने आजादी दिलाई? No. There were thousands and thousands of people there who lost their lives and all that. Similarly, the digital revolution, it is there, but then it is supported by many other things. And out of that, compression is the most important. Today, you just remove compression from digital revolution, you will be nowhere because bandwidth, so much bandwidth will be required, so much things will be required that you will not be able to handle these bits. Yeah.
These two were the questions
Okay.
that I have received so far.
Okay. So anyway, others we will take up afterwards. No problem. No problem. And now these things I have just written. Whatever I have told you, I have just written. For students only, that how the oranges and video signal. The whole idea was that the video signal and oranges, once you compare, you at least know the what is happening. Okay. Now we come to the we try to study, and first we will study because we are compressing the video signal. So let us see, let us understand the video signal first. Now, when the video signal is there, well, I normally define it in the 4 dimension because in compression this thing will come. One is the magnitude of the sample, then horizontal is spatial axis, vertical is spatial axis, and then time domain because video is moving. Time factor also comes. So this is one way of. I'm just giving you the video signal definition in different ways. The second is video signal has got as component video. Now there are 3 primary colors. We all know it: red, green, blue. Primary colors, and each color has got bandwidth of about 5 megahertz. But then naturally, when we compress it, it will be much less. Then we say that the video signal also can be represented. There are 2 things: luminance signal and chrominance signal. Now, luminance signal has got bandwidth of 0 to 5 megahertz, whereas chrominance, we all know that chrominance, our eyes are less sensitive as far as color is concerned. So here we convert this signal into R minus Y and B minus Y, and then we use only 0 to 1 megahertz. And because these things I cannot take into detail, then the time will not be sufficient. Okay, third, the luminance composite video consists of luminance signal Y, chrominance signal, and then in the form of suppressed carrier point, then R minus Y, B minus Y. Then they have the bandwidth around 2 to 5 megahertz. Then there are 2 important things here which I will be using it. The video signal consists of 2 things. One is spatial domain information, and second is temporal domain information. Now, what does it mean? We all know that the video signal, when we see the TV, it is not the uniform. It is sent in the form of frames. They go frame by frame. So we all know that. Now each frame has got some information, right? And then when the one, suppose there are 12 frames, then one frame has got some information and say 12 frames per second. Then that thing will change in the next frame. For example, Kohli has hit a shot. Now the bat will move from frame to frame, So there will be information in one frame which will change, few things will change in all the frames. So the information which is there in each frame is called spatial domain information. Is called spatial domain information. And the information which is changing frame by frame, that means in one frame it is something, then in another frame it is changing, that is called temporal domain information. Okay. So this is provided in each frame, spatial domain information, and this is provided difference of the two frames. This will be more clear when I go to the other technical details. Okay. Then, as I used in the beginning, that video signal has got three elements, I told you. Core element, redundant element, and irrelevant. This just now we have seen in our analogy also. So video signal has got these three things. And then lastly, if you define each frame, the frame has got fields and field has got lines. Lines are there, and on the lines there are pixels. Okay. Now pixel comprises of luminance and chrominance. So luminance will consist normally of brightness, and the chrominance will consist of color information. So frame, field, lines, pixels, and again to brightness and color information. This is, in short, I have made what is video signal. So we will proceed with this background. So now we take concept map for video compression. Okay. Now, please now remember one thing. Everybody should remember one thing. Now, I have come to a stage where I know when digitization takes place, analog video has got huge quantity of bits. So my aim is go on reducing these bits. Okay, because when we generated, it was about 16 megabits per second, and slowly we are supplying only 3, 4, or 5 megabits per second. So in between, how we are removing this huge quantity of bits. So now onwards, it will be only we will be concentrating on the techniques which we will be using. So first is spectral redundancy. So these are the redundancy. When we remove the bits, we have to know कि भाई इसमें क्या क्या फालतू है. So what are the things which are redundant, which we can remove? You just can't remove anything you like, because then your video signal will go bad. Then people will not be able to see the picture. So we have to find out redundancy. So in redundancy, we take first is spectral. In fact, this is a part of analog also. Then spatial domain, spatial redundancy. Spatial redundancy means in one frame there are many things redundant, which I will be telling you just now, after this. Spatial redundancy means redundant bits in one frame. Redundant bits in one frame. That is called spatial redundancy. Then temporal redundancy. Temporal redundancy means between the two frames, there are many things common. Okay, I will give you a simple example. Say you are reading the news. Now, when you are reading the news, frame will remain at least for 5-7 seconds. So during that time, what is happening? Only your lips are moving. Sound is coming. That's all. Otherwise, everything remains the same. That means for few seconds means if it is 12 frames per second, then at least for 60-70 frames, Nothing will change except your lips are moving. So why we are sending the details in every frame? So the difference between the two, we send only the movement of the lips or whatever movement is there. That is called temporal redundancy. Then psychovisual. Well, that is being used in sports and all that. Supposing there is a big match is going on and we are covering that, and again we want less bandwidth. So what is important in cricket match? Well, player on the pitch, the uh, player is important, his bat is important, his cap is important, ball is important. These are the things which are important. You have to give all the details about these things. Now, thousands of people are sitting around in the stadium. Why we should send the details of all in every frame? No, there is no need. Only you send the signal once about the whole thing, and then you tell the decoder, भाई इसी को लगाते रहो, इसको again why? Because even if 5-10 people move in between, nothing will happen. Similarly, the grass in the field, you need not give each and every detail. So like that, there are many things which our mind will not notice. Our mind will not notice that. That is called psychovisual. Even I will give you another example. Psychovisual means, suppose in some frame car is moving very fast. Now when car is moving, your eyes cannot catch every bit of it, because car has got lot of bits, it's information. But when the car is moving, you only see the car moving, so your mind will take, psychovisual will take only that car is moving. So you need not give all the details of the car. Only you have to show something and then just see that it is moving. That is called psychovisual. Then comes entropy. Now I am giving you just a little bit because I am afraid of the time. So entropy means, I give you another example. Say you are writing something, you are typing something in English, no, A, B, whatever letter you are typing. Now, say for each letter you are giving some bits, say 3 bits or 4 bits or 5 bits for each, right? And then you calculate the how many bits have been used in one page. Say n number of bits have been used. But what are the alphabets which are coming very very rarely? Or first let us see what are the things which are coming quite regularly. That is A, E, I, O. I mean, these things are coming very frequently. So you have to give more bits to these ones because they are coming very frequently. But if somebody's name is Z, Zivasky or something like that, they are coming rarely. So you can give them longer bits, but because they are coming less. Now with this, if you calculate, you will find that number of bits reduced is less. Number of bits have been reduced. Another example, say you are sending the bit, after all bit stream is going, right? Now what will be there in the bit stream? Either 1 or 0, right? So 1 or 0 means there will be, say there may be 1100, 1100, like that, they are there. Now you need not send all the details. Suppose sometimes 10 ones have come, it may come. So you need not send 10 ones. You just send some code that when one is coming, you treat it as 10. And similarly, say 101010 is coming 10 times. So you send just once and then with a code that you please count it so many times. So that is all is called entropy redundancy. Okay, so compression means exploiting limitations in human visual system and human audio system. This I have already explained. Compression means, I'm giving the definition of compression in different ways. Bit rate reduction. Why? For storage and for transmission. This also I have explained in my orange juice analogy. Then compression are of two types. One is lossy compression and one is lossless compression. Now the question is, in our TV transmission and all that, we use only loss. Because it doesn't matter if there is slightly quality and all that. After all, when you are getting compression, there are encoders which are giving compression up to 200 is to 1, 150 is to 1, 250 is to 1. So much compression they are giving. And that's why we are having less bandwidth requirement. But lossless compression is required only where you cannot afford to have even 1 bit loss. Example, suppose you have written a program and it has got naturally number of bits, so many things, you have written a program. Now you are sending this program to somebody by compressing it. Even if 1 bit is lost, your program will not run. I think you all know it. So in lossless compression, but the lossless compression will give you only 2 is to 1 or 2.5 is to 1, not more than that. Whereas lossy compression will give you huge amount of bits removed. So these are the two, lossless and lossy. Okay, so now we come to some coding techniques. Let us see how exactly we remove the uh, bits in the compression. There are different types. I will see how much time we have so that we can discuss. One is called spatial coding, another is called temporal coding, entropy coding, and motion estimation and motion. I think leaving except this last one, I have already explained you little bit, but we will see. We will see. Okay. Now, first we will take only in one frame. Let us take a frame. So this is my one frame. Normally we send 25 frames per second or whatever is there standards. Then each frame has got lines. Each frame has got 525 lines. Then each line has got pixels, 704 pixels per line. So you can imagine how many bits are required. 25 frames, 525 lines, 704 pixels. Now, in this, you have seen when this lady is reading news, behind this lady, there is only one screen, okay, which is absolutely, plain. There is no variation. But then, what is changing as far as picture is concerned? Whatever is her face is there, that is important to us. You have to send the face, the bits of the face, which I have put it here in yellowish color. So these bits are important for me, whereas these bits are redundant. Again, I repeat, these bits are redundant, whereas these bits are important for me. Now, I request you to correlate this one with my orange juice. Orange juice में क्या था? Pulp was the main thing. Pulp. Now here, what is pulp? These yellow bits are the pulp because that is the main signal. That is the main picture which we have to send. That is pulp. Whereas what is redundant? These other bits are just redundant. You send one or two for sample and tell them to put all that bit except this picture. Now, how much bits you are saving? This is called spatial coding. I hope I'm explaining in a very simple way. You must have understood. I repeat, only the picture is pulp, whereas all other background is like water. So you need not send the water. You only send the tails of the pulp, and then you will have this compression. That means you have reduced you have removed lot of bits. So picture pixels are nothing but pulp in the orange juice. Other pixels are nothing but water in the orange juice. I am just comparing the two with my orange juice and then here. Okay. So information describing only picture is passed from one frame to other frame. Now in spatial coding, what happens? Whatever information is there in one and we pass it on to the next. This type of coding is called spatial coding or intra-coding or iPicture. Many of you must be knowing IPB. So there are three names for this type of, see here we have removed bits. That means coding we have done. And removing those bits, that coding is called either spatial coding because it is only in one frame, or intra coding means within the one frame, or it is called iPicture. Okay. Now, here this is again important. See, our eyes, God has made our eyes, and human vision sensitivity is also very peculiar, my dear. This side is spatial frequency, and this side, vertical axis, y axis, is human vision sensitivity. Now, spatial frequency means what? I will explain you. Same, there is a big tree, नीम का tree या कोई भी tree है. So tree का जो main बड़ा बड़ा branches है, whatever branches are there of the tree, that is all low frequency. Low frequency. And उसमें जो पत्तियां हैं, पत्ती के अंदर जो डिजाइन बना हुआ है, that is high frequency. Okay. Similarly, in your room, you can see in the room there is fan, there is light, there is TV, there is AC, there are so many things. They are all low frequency. Whereas curtain is there, that is also low frequency. लेकिन curtain के अंदर जो छोटा छोटा design बना है, whatever design is there, that is high frequency. Now, our eye sensitivity, which has God has given us this graph, it is not made by me or anybody. That low frequency, our vision sensitivity is very, very high. That means low frequency items, we cannot play any trick, because after all compression is all trick. So we cannot do any jugglery in the low frequency component. Whereas high frequency components in the vision sensitivity is very less, so we can do lot of jugglery in that, which I will show you. But otherwise, this graph is very, very important. I hope somebody has understood. Otherwise, you can put it in the chat box. I can explain you again. So this is called intra coding. This I have done already. It is by just whatever I have told you. This is just written here. High frequency bands can be described by fewer bits. So high frequency components, we can give only few bits, whereas we have to give VIP treatment to the low frequency. In a lighter way, I say जो लो फ्रिक्वेंसी के कंपोनेंट हैं उनको तो आप अच्छा खाना खिलाइए, बाकी को हाई फ्रिक्वेंसी वाले को लंगर खिलाइए. Okay. Now I come to temporal coding. Now in temporal coding, what happens? Again, I will that is between the pictures. It is not one, you know. Now this is bit complicated. So what I will see, I will just use the information in the picture, and then I will tell you. Okay. So these are the two frames. Then the coding is done between the two frames. That is one thing. Right? Yeah. Say, this will explain my things in a better way. Say, we have a frame here in front of us. Now this frame has got few details, like few pictures. There is a house, there is a car, there is an aeroplane, there is a horse, and all that. And this picture we have to compress. Okay. Now, before this frame, that is n-1 frame, earlier frame was also having two of these elements. That is, car was there and the horse was there, right? But these two things were not there. And the frame which is coming after this has got again two things. House is there, aeroplane is there. Now we have to compress this middle one. So what we say, we need not send all the details of the aeroplane, car, horse and house. No. When we are sending this, we say, भाई इसके पहले जो frame आया था, the frame which was before this, उसमें से आप थोड़ा detail, you take some details like horse का, car का, you take that. Okay. So my moderation is less. And then I also send a message that the frame which is coming after this frame also has got some information of this frame, that is aeroplane and house. You take it from that. That means, my dear, as far as this frame is concerned, which is under consideration, I am not sending any bits as far as details are concerned. Two things I have given to the earlier frame and two things I have given to the frame which is coming later. Then whatever little bit is there, I am sending that. This is called temporal coding and this is called B-frame or bidirectional. Is that all right? This is called bidirectional coding. Yeah. So normally, even in P picture, I think, yeah. In this, as I was telling you, suppose these two pictures are there. Now, I have already sent this picture. Okay. The receiver has received and encoder has received this picture. Now I have to send this picture where there is very little difference. Suppose he is reading news or something, so either eyes are moving or lips are moving, something like that. So I need not send this frame again. Why should I send? So I have already sent. So what I do? I take the difference of these two frames. I take the difference of these two frames and I send the message. Please, the frame which I have sent you earlier, that is my end frame, in that you add this difference. And once you add this difference, it will become n plus 1 frame. I think it should be clear. So n frame and n plus 1, both the frames will be available to the decoder. But I am sending bits of only one this frame. So this way it is temporal coding and this is called intercoding or this is called their spatial coding. It was called spatial coding or intra-coding or I picture, intra-coding. Here, when we are sending only the difference, it is called temporal coding or intercoding or P picture. Okay. And even when we are not sending anything of the frame, we are only telling them, you take this from here, you take that from here. That means we are sending very, very small number of bits. That is called bidirectional or B picture. So in temporal coding, in this we make three types of picture: I picture, P picture, and B picture. I picture, P picture, and B picture. Now, if I ask somebody, suppose some frame is there, I make it. I can make it I picture also, I can make it P also, and I can make it B also. It all depends upon me because I have got all the facility. Now, if I ask you, if the same picture is made I, B, or P, which one will have maximum bits? I can't hear you, or that means, but somebody can write in the chat box. Which which frame will have maximum bits? It will be intra. Okay. And secondly, which will have less? Second, that is intercom. That means between the two frames you are sending less number of bits. And minimum bits are required by B frame, that is called bidirectional, because it is taking some information from one direction, some information from other direction, and then you are making the picture. So I, P, and P. P requires minimum possible bits for the same frame. P will require more than that and I will require maximum. Normally the thumb rule is whatever bits are required by I, 50% of that is required by P, and 50% of P is required by B. That means B has got only 25%, whereas P or I are having different mode. So this is the beauty of compression, temporal coding. So I have now very interesting thing comes when we are sending the video signal. We all know that the signal is sent by the frame, and these frames are going. So in what form we should send the frame? Well, somebody will say, sir, B का तो सबसे कम लगता है, तो सारा B भेज दो. अरे भाई सारा B भेजने से बाकी फ्रेम कहाँ से बनेगा? So we have to make a system that first of all in one block, suppose 12 frames group is there, 12 frame का एक group है, and we are sending in each group there should be at least one eye picture intra. Why? Because P will be made only with respect to I. वो I से ही तो लेगा ना difference. And B will be made with the help of those two frames. I know it is little difficult, but I hope try to understand. Otherwise, in the end, ask me. I can repeat. So again, I repeat. I picture has got almost all the information, but P picture will depend on I picture because it will take some information from P picture, I picture, and B will have minimum information because it will take some information from left side and some information from. Yeah, this I have explained, so I will not. Yeah, here it is B picture. Now you can see that B picture is made on the one side, it is taking the help of I picture, another side it is taking the P picture. This P picture is taking the help of P and this. See, B picture will not take help of another B picture because B is already on clutches. So B picture cannot support any frame. B picture will only take the support, it will not give any support. So you can see that if B picture is made, it is from the left hand side and right hand side. Okay. Now, so we can see the spatial and temporal redundancy here. So this is our left side RGB picture is there. We convert it into YUV, luminance and chrominance, you know it. And then each frame is converted into blocks. Each frame is converted into blocks, and then the blocks are further made small blocks, and then we are doing a very great jugglery that, of course, I would like to explain. If madam allows me, I don't know how much time. But yeah, motion estimation and madam, how much time you will give me?
Sir, it is up to you, sir,
No,
as
I
you
can
want to
continue.
take.
There's no problem. It is for the people who are listening, their tolerance and your decision. Okay.
Yes, sir.
So let me continue. Now, friends, what happens in motion estimation and motion compensation? Say, in one frame, in one corner, in the car was in one corner, and in the next frame, that car has moved to the other corner of the same frame. That is, frame is same, but the car has moved from one to other. Now, if actually technically that both the frames are different because car is in different position. Car is in different position, and car has got lot of bits to make. Car we have to give lot of bits. Now, why should I give bits again? So what I do, I give bits to one car on one position, and then I tell them that Baba, this car is going from this point to the other point. I am sending you only the vector. That means length of the vector and the angle. You know, vector has got two dimensions. One is magnitude, another is angle. So I am giving you this vector, you put it in this frame and move the car from here to here. Now, since you have got all the information of the car, so you have to simply shift this car from one end to another by using only vector. And you know, vector will take only few bits by here. Vector ज़्यादा weight नहीं लेगा. So this is called motion estimation. First, we estimate the motion and then we compensate it by sending the vector. I mean, this is how simply I can explain this. Well, you can see here, for example, it was here, this point, and then it has gone there. So we move this vector. No, we give the details of the vector, and this point is moved from one to other. Okay. So bit streams, you all know that the our all after digitization, all these bits will be moving. Okay, and as I told you, they move in the GOP and a group of pictures. Now GOP may be of 15 frames, it may be of 12 frames, or it may be of 9, depending upon what you want to send it. So this again, because this is the MPEG stream, this stream is going where there are GOPs different. This GOP of, as I told you, maybe say, let us say 12 frames. So in every layer, there will be information that is called header. Header will have all informations, whatever is necessary about that picture. So then GOP will be there. And below in each GOP, there will be again header, and in each GOP, there will be pictures. How many pictures? Either 12 or 15 or 9. Okay, it depends, how much. So GOP, and then each GOP has got pictures. Each picture has got slides. If you convert each picture into slides, just like bread slides. So slides are there. Again, they will also have header. So slice is there. And then macro block. We have got a macro block. And from we have got block. Now each block normally in video is 8 by 8. That means how many pixels are there? 64. So we process it block wise. Each block will have 8 by 8 pixels. And then each block will have coefficients. So this is how the bit stream is moved in the video signal. Well, as I told you that there is GOP is how we have to send it. If you send only all I pictures, well, quality will be very good, no doubt, because it will have all the information. But I picture, as you know, it has got a lot of information, so a lot of bits. So naturally, bandwidth will not be there. But if you send only IB, then the quality will be. This lower side is lower quality, this side, and higher side. It has been found that the sequence is normally IBBP. Means you send I picture, then two B pictures, and then P picture. They found that if you send the frames like this, you will get the best quality. I means intra, it has got maximum. B means bidirectional, minimum, and P again less than I but more than P. Okay, now we come to this important thing. See, the whole compression things so far what we have discussed, it is all, we have talked in time domain. We know that time domain, but all these tricks cannot be done in time domain. We have to convert it into frequency domain. That is one thing. And that's why we call it DCT, discrete cosine transformation. Yani ki we take the sample and we convert it into DCT. See, when you take any analog signal, And when Fourier has already given this analysis, in fact, yeah, say this is the rectangle, and then you convert it, it has got all the frequencies. Now the question is that if I ask somebody how many frequencies are there in this one rectangle, or in other words, how much bandwidth will be required to transmit this rectangular wave, it will be infinite, because this rectangular wave shape has got all the frequencies. So that is the extreme end. And how many frequencies just one sine wave has got? Only one spot frequency. So there are two extreme things. Our any video signal will be in between. So when you take any video signal, it will have fundamental, it will have second harmonics, third harmonics, and so on. So we have to convert all these into the discrete. So if you convert any analog signal, I think you all know that you get two components. A sine theta, sine omega t, cos omega t plus minus j omega t, plus minus j omega t. They are identical. They are separated by only 90 degrees. I think you all know. That means they are identical. Now we have to take, we want only one because one is sufficient for us. We need not, because they are identical. It is just like twins. Twins are born, but here suppose the twins are there. We don't want both. We want to remove one. So which one you will remove? Whether sine or cosine. Now here we say we remove sine. Why? Then we keep cosine. That's why it is called DCT, discrete cosine transformation. It may be DST, discrete sine transformation. But why we don't take sine? Because this sine component has got omega, I mean this iota, and the value of that is under the root minus 1. I think you all know j cos theta plus j sin theta. So in cos theta it is always a real value, whereas in sine it will be real imaginary. Why? Because when square is there, that is removed under the root, but when cube is there, it is there. So this I will be troubling us. So we remove this I and we take only DCT. Okay. Removing techniques are there, so I will not go into the detail. Just we compare put the two things. But I want to tell you something interesting. So what we do, we convert the signal with the help of DCT, discrete cosine transformation, and it is a wonderful thing. We take any analog signal, it is a chip actually. We take any analog signal and that it will decompose it into all the frequencies, like you can see in this picture. All different frequencies are there. This is the minimum frequency, that is DC component, 0 frequency, and this side is maximum frequency. So now you can see that all the frequencies are in front of you. My dear, I will give you again one very interesting analogy. Suppose somebody is sick and he is getting fever and all that. So doctor gives him some medicine, but he is not all right. His pain is still there in the stomach. So he gives another, then he takes some test and this and that, and then he says, "Bhaiya, transformation karna padega." Means you get admitted, we have to operate. He will open his heart, he will remove the whole heart, he will change the valve, etc., and again pack it. Inverse DCT. So like that, when we do the DCT, all the frequencies are in front of us. Now, when they are in front of us, we know our eye sensitivity is only for low frequency, whereas high frequency, our eyes are not sensitive. So यहाँ पर हम discrimination कर सकते हैं. We can do the discrimination. We can give more bits to this and less number of bits or no bits to this one. This will be clear by this DCT example. Yeah. Supposing this, I am taking one small pixel. This is 4 by 4 pixel. not 8 by 8, 4 by 4. Now, this is before DCT. Before DCT, every pixel has got these values. Okay. Now we don't know in each pixel what are the frequencies available. So when you are giving bits, you have to give bits to all, and that will consume lot of bits. But if you convert it into DCT, now what DCT will do? DCT will put zero frequency here, and then it will increase. It will increase highest frequency here. So now your things will change from here to here. Now you can see this was the main block before, and now this is my quantization table, and this quantization table is proportional to your eye vision, sensitivity, how your eyes behave, and we know that our eyes behave better for low frequency and less sensitive to high frequency. So what we do, we give boost to low frequency and we reduce the high frequency. And after this rounding, what we get here? Only 2-3 components are there where we have to give bits. Rest are all zero. And again, my friend, I remind you, all these zeros are nothing but water in the orange. All these zeros are nothing but water in the orange juice. We send signals, we send bits only for these 2-3. We remove even these also. One is not much value. So we only send bits for this. And we tell them rest is just put the water. Now, before this, what was there? Here you have to send bits for all. So huge quantity of bits are there. But here you are sending bits only to P. So how much you are saving with the help of this DCT? So DCT is a wonderful tool. Now see, but see, every good thing has got some drawbacks also. So I should not hide this. Now first see these two pictures. Now when the colors are changing, that means frequencies are there. Say white is there, then some other color and all that. But here all frequencies are there. So that's why color is like this. But now what I have done, I have removed high frequency. So moment I remove high frequency, this picture becomes this picture becomes this picture. अब इसका असर क्या होगा? What will be the effect on the, suppose some swimming competition is there where we are applying this DCT spatial redundancy, and if you see the two frames, my dear, do you notice anything? This picture is far better because high frequencies are also there. Whereas in this one, you find these greenish spots even on the face or other places also. But if it is a swimming competition, who bothers for this? For these spots and all that. We are interested only who comes first and second. So DCT is applied where details are not required, and you can just put it like that. Okay. Similarly here, suppose this picture is there. We take one block. Now all these are before DCT. And here you can see that if you have to give the bits, then you have to give huge quantity of it. But once you have done DCT, see that this picture becomes how much? All most of them are zero. Only few values are there for which you have to give bits. So they are all water in the orange. Now I will just show you the last I want to remove. I will only show you how DCT affects our quality. Yes. Yeah. Okay. Now here what happens? This is the original Saturn image. Original. And when we are doing DCT and all that, we are taking one block 8 by 8 block. 8 by 8 means 64 coefficients. 8 this side, 8 this side, 64. Okay. Now this Saturn, right now we are taking all the coefficient, all the 64. I mean, you are taking 1 point and you are taking all the 64. So what will happen? This original and then this reconstructed. This is reconstructed. They are exactly identical because there is no error. You are taking all the frequencies, isn't it? You are taking all the frequencies. So there is no error. Now what I will do, I will go on removing some blocks. Okay. These black ones I have removed. And again I reconstruct the picture. Now you will find some error will be there. Right now you cannot see unless you come very close. You will find some here. This is actually this minus this because we have removed some. Now you go further. Now I have removed only I have selected 44 coefficient out of 64, and you find that still the picture is good enough. But some error is increasing. Error is increasing here. Similarly, if you take this again, I am taking only 34 coefficients out of 64. Again, it is tolerable, but now the error has increased. You can see if you come nearby, you can see the same image here. This is error. I reduce further. I take only 24 coefficients, and you can see that the error has again increased. But still, picture can manage. We can manage. Nobody can differentiate much. And then now I take only 20 coefficients. Now the error has increased. And I take only 18 coefficients. Rest I have removed. It's still quite okay. That is the advantage of DC. Because DC main thing is here. And you find that this is error has increased, but this picture is still there. I further reduce. I take only 14 coefficients. Again, this is the difference of the picture. But error is increasing slowly. Now you can see the error. It is almost same type, but still the picture is tolerable. If you take 10 coefficients only, now you can see the edges are becoming very sharp. Here the error. So this is a reconstructed image, and this is and if you take only 6 coefficients, now the error has increased and picture is also deteriorating fast. You can see the difference between this picture and this picture. There is some deterioration because we are taking only 6 coefficients, my dear. Others we have already removed. And if you take only 3, now you can see the error is tremendous. But you are taking only 3 coefficients. So, and this is just one of course, it is unbearable. You can't. So this is how we are giving, DCT, and then it is increasing. I think so. I should leave some time for the answer also. So, madam, I will not take much because I will not go further because I will prefer some questions also.
Sir, I think I am done with the questions as far as like now we have not received questions anymore.
But anybody if he is interested, they can ask.
Yeah, sir. For now, I don't have any questions.
Okay.
Yes, sir. The 2 questions that I received, I have taken them.
Okay.
Yes, sir.
So anyway, then I would like to finish here. Of course, I have not done uh, audio compression. This is even video, and video also I have done a very small. Otherwise, compression is a very vast subject. Okay. So
Okay,
here
sir.
I would like to stop, and if there is anything, then we can. Then
So I feel I am sure that this insightful session would have been enlightened the participants about the real life applications and the knowledge. And now, far, sir, I can see one such question raising up on the chat window. They are asking about your thought about AI compression using auto encoders.
You mean to, you are talking about AI, artificial
What are
intelligence?
your
Yeah,
what are your thoughts about AI compression
that's
using auto
that's a
encoding?
very good question. In fact, I am working on AI also, and AI is some technology which is entering everywhere. Now here also, because as you know that AI is dependent only on data. That AI works, any AI will work only on data. So here, when you are working on the compression, again we have to see about the data, what type of data is there and how much we can reduce. I have not gone into much detail, but I am certainly working on it. And AI is already there, and people are working on AI in compression. Yeah. Any other question, madam? Good evening.
Oh, good evening, Sinsab. Good evening. Your lecture was very inspiring in the beginning at the outset. Before you started, I could not give the welcome address because today I was
No. That is not required. In fact,
flight.
when you are
But
meeting,
then after I joined, and it was so inspiring. And what could have been a better occasion than today of Dhanteras,
yeah,
when we are talking of optimizing not only the technical side, the bandwidth and other aspects, but
yeah,
also optimization of economics, and
yes,
that too a lecture on Dhanteras. Huh? Thank
yes.
you
Oh,
so much.
this
Thank
is
you.
also economics. In fact, this is techno-economics. That is, we
Oh
can say.
yeah.
Definitely.
Absolutely.
Then,
This is
if we are
economic.
saving the bandwidth, so
Correct.
once we are saving the bandwidth, then it is there.
Absolutely.
Yeah,
And the topic is so vast that
yeah,
this
very fast.
1 hour is not sufficient. That's how many things
But in fact,
you could
sir, I have not
wanted to speak could
touched
not.
even audio compression. Audio compression is
Right.
also
But
equally interesting, but the technology is different.
correct. But
In audio
nonetheless, we'll have
compression,
another session
yeah,
for the
we can have
parts which
another
are
session
remaining
and
today. And thank you so much. I
thank you.
also take this opportunity to pay my congratulations, greetings for Dhanteras,
Yeah, same to
Happy
you. I
Deepavali,
also,
Bhai Dooj, Govardhan Puja, everything to you and
yes,
all
sir.
my participants and
Thank,
panelists from various parts of the country and abroad.
thank,
So thank
thank,
you so much.
thank you very much, sir. Thank you.
And we'll meet again.
Sure.
So kindly accept this memento from our end as a gratitude from DVI Camp family.
Well, thank you. Yeah.
These certificates and mementos are only for your remembrance.
Yes, sir. No,
That you
sir.
have been
They are
part of
good.
such one.
Yes. Certainly,
Thank you so
they are encouraging, sir. They are encouraging. So, but somebody has asked very interesting question whether AI is entering. I want to combine AI and compression. That is the latest.
Oh yes.
Yeah.
Oh yes. Oh
So,
yes.
so I am working on it, but still that is very interesting. AI in
That just
compression.
give me one abstract will have it.
Yeah.
Right.
Thank you
Thank you
so
so
much,
much.
sir. Thank you.
Thank you, sir. Thank you, madam.
Thank you, dear
Over to you.
participants.
Bye.
Dear participants, this meeting is converted to a facilitation center to resolve your queries related to certificates. Has been shared in the chat window. Please
Yeah.
use the feedback link to submit your feedback. Based on your feedback, the data will be collected from there. Your certificate will be created. Its PDF will be written, and that PDF file will be attached in an email and will be delivered at your inbox. And this entire process must happen within 2 minutes. If you are not receiving your inbox, do check your spam folder. And if it's not there in the spam folder, you have successfully filled up the feedback. My request will be to please write your name and ID in that window. The team Uttar Manish, they will be taking care that you certificate. That is the location where the certificate is saved. You chat window. So thank you so much and wish you again once a very happy Dhanteras, Deepavali, Lakshmi Pujan, and of course the Govardhan Puja and the Bhai Dooj. It was so novel and so enriching that many of Indian festivals are connected with. Thank you so much. Wish you all the best. God bless you all. Stay safe, stay healthy, and keep learning, keep attending our webinars. All the best to you. Ayushi, are you now audible?
Yes, sir.
Oh, yes. Oh, yes. So thank you so much.
Okay. Thank you,
And
dear
you can
participants. Yes, sir. I'll connect. Take
we have
over.
we have 20 minutes. We have 20 minutes. So all the participants are requested to please fill up the form within 20 minutes. 8 p.m. We'll be closing the room. Thank you so much. Over to you, Ayushi.
Thank you, sir. Dear participants, you are requested to find the link from the chat window and fill up the feedback form for the smooth generation of your certification of participation. Also, dear participants, all the recorded activities and this session also would be available on our YouTube channel. Kindly subscribe the same for regular updates and for looking up to the session.